My name is Mark Jerick. I'm director of the Northern Crops Institute, and it's my pleasure to welcome you to this month's edition of Cereal Innovators. We're very pleased to have our friends from BoMill presenting here this week. It's pretty interesting technology, and I think it's something that can add a lot of value to the grain industry. So we're always interested in helping our viewers try and add value. So the Northern Crops Institute is a 4-state collaboration between Minnesota, Montana, North Dakota, and South Dakota. We're based on the campus of NDSU in Fargo, North Dakota. We are governed by a governing board called the Northern Crops Council, made up of farmer, business, and government leaders from the 4 states. We provide technical services in addition to courses and training. Our mission is to support regional agriculture and value-added processing by conducting educational and technical programs that expand and maintain domestic and international markets for northern grown crops. Some of our technical services, we have a full suite of baking equipment, so we can do a wide range of bake and flatbreads. We do have extrusion technology. We've got a Winger twin screw extruder that we use with clients. In addition, a full range of soy milk and soy food equipment as well. We also offer oilseed processing, extraction, refinement, cold press, protein isolation, cooking quality. That extraction includes hexane extraction. So if you're working in the oilseed industry and need some help trying to figure out how to extract some of that oil, you can reach out to us. We also do a large amount of pasta work. So we've got 52 long and short good shapes. We can do dry and fresh pasta, lab or pilot scale, in addition to specialty pasta. In addition to all that, we also do milling. So whether that's grains, pulses, oilseed, we have the capability to pilot scale milling, bench and small test mills, and just a wide range of dry ingredient mixing and blending. We do have our wheat quality handbook that is available now at our website, www.northern-crops.com. In addition, we have our Ancient Grains of the Great Plains handbook available now as well. A couple of things to make sure we have on your radar. So September 13th, we're talking sustainability with our friends at Nutures. And then our market update, August 16th, we've got Joel Vince talking about the latest World Agricultural Supply and Demand update. We're talking Durham Special Edition on September 6th, and we're back to our WASD with Allison Thompson on the 20th. Future feeding, we'll be talking about DDGs, Incorporation of Dairy and Beef Cattle with Isaac Sulfur, University of Minnesota, Everything Ethanol. We'll be talking about sustainability and ethanol, a global outlook with Brian Healy. And just a reminder, we do have those handbooks available. All of this information, all of our webinars, all of our past webinars available at www.northern-crops.com. We do have an on-demand course that's launching, developing innovations with durum, much more than pasta. So talking about breads, talking about other food products that you can make with durum. Do you want to have a bit of a disclaimer? The views, information, or opinions expressed during the series are solely those of the individuals involved and do not necessarily represent those of NCI or its employees, and we do not discriminate in any of our programs. Just a reminder, these webinars are always better when there's dialogue and conversation, so you can please use the chat function located at the bottom of your screen, and I will relay those questions, and hopefully we have a good conversation here today. We do want to thank our friends at North Dakota Barley for sponsoring this webinar series, so we can't do these without the support of our sponsors. With that, it is my pleasure to introduce our presenter today. Hansi Biedermann holds a MSc from Lund University in Sweden in the field of nanoscience. He started at BoMill in 2009 and has over 14 years of experience in the grains processing industry. During this time, he's held various positions in the company focusing on product development and customer installations, and he's been a key member of the team developing BoMill Insight, which launched in early 2023. So with that, Hansi, I'll turn it over to you.
Well, thank you very much, Mark. I'm really happy for this opportunity to present here in the Cereal Innovators webinar. I'm also glad to have Dylan and Dave with me from Bratnik Companies, that is our distributor in the US. And I might shoot out some questions to you guys during the presentation. So during this presentation, I will tell you about BoMill and what we do and how we believe it will impact the industry. But first, I will talk about variation. More specifically, quality variation. So there are known variations within a field of grain. It can be due to elevation, available water, exposure to sun, etc. So this is commonly known, but what is not known for most, not even in the industry, is that there are big variations between the kernels on the same spike. Even if they are sprung from the same seed kernel and actually are twins, there are significant differences between the kernels on important quality parameters, such as protein content, for instance, which is visualized here in this image. But when the industry deals with grain, they are always subjected to the averages, simply because there is no way to check the quality of the individual kernels. For all they care, all the kernels in a specific batch are of the same quality, as shown in the left image. So what you typically do when you try to target a certain quality is either to source your material from somewhere else or blend different qualities to achieve your desired quality. But what we can clearly see from the image to the right is that in reality, the batch of grain is a mixture of kernels with different qualities, and that the desired quality is most of the time present in the material you already have. It is just that you have no means of retrieving it. And furthermore, what you have done now by blending your batches in order to achieve the desired quality is that you have increased the variation within the grain, or inhomogeneity. And this is also affecting the predictability of the subsequent processing of the material. Now, because you have this wide range of variation within each grain lot, and this is true no matter how small the sample is, this poses an untapped opportunity. But how do we take advantage of this? Well, let's look at what's available in terms of equipment today. The grain industry has, since industrialization some 100 plus years ago, used various equipment for cleaning grains, which is more or less the same type of equipment used today. The most significant innovation introduced is the color sorter that has over the years evolved into being a standard in many industries. The similarities between all these technologies is the limitation of determining quality on size, shape, and color differences. Neither of them are able to analyze what is inside the different kernels. Also, you have the near-infrared laboratory machines that are used to determine protein content, moisture content, etc. for grain batches. But these are also only averages. So they are not able to look into the individual kernels. With the introduction of BoMill Insight, we are in industrial capacity analyzing and sorting kernel by kernel on its inner properties, which arguably would be the first true innovation in the grain industry for a very long time. And so this is what it looks like. And it does single kernel sorting using near-infrared transmittance. That is the same technology that is used in the benchtop lab units, but we use it on each individual kernel to assess the inequalities. And the capacity is up to 15 metric tons per hour, so well in line with the industrial needs in the industry today. So if we take a closer look at what's actually being done, the sorting consists of a three-step process. The first step being the singulation. And this is basically where you take the kernels from a batch and get them all one by one in order to do the measurement and subsequent sorting. And this is not hard to do when you're not trying to do it in industrial capacity. So industrial capacity in our case would be roughly 125,000 kernels per second that need to be perfectly aligned in order for the measurement to be properly conducted. The second step is the detection. And this is where we are unique in the industry. We use near infrared light in transmittance mode. And this basically means that we use near infrared light, we shine it onto the kernel. The light that has passed through the kernel is then detected. And this measurement can be used to predict the qualities such as protein content or fusarium damage for that individual kernel. And the third and final step is called the ejection. Here we use compressed air to, based on the previous measurement, decide whether or not the grain should pass into the main outlet or get ejected into a secondary outlet. And so one unique feature here that I also should mention is that this is all taking place on a chute. So what you see in the background image. And the novelty here, besides the near infrared detector, is that both the detector and ejector are built into this chute. So you get an unprecedented accuracy, both for the measurement, but also for the ejection. So what happens when you run a batch of grain through the machine? Well, it aligns all the grains according to the measured quality and build up a sort of a bell curve. And from here, you simply introduce a threshold. And that threshold is then dividing the grains into two separate fractions. So if you had 11% protein on average, you have now divided it into two fractions, one with 10.5 and the other one with 11.5. So this allows you to create two completely new qualities out of the original quality of 11% protein. So what can you do with this? Well, one application is if you want to target specifically a high protein. It might be that you have a premium for a high protein. So let's say you want to have 12% protein, but you only have 11. By simply moving the threshold a bit further to the right, you can select a more narrow range of really high protein kernels. And that way you can generate your own 12% protein fraction from a material that's originally at 11%. Another application is if you are having trouble with fusarium and you want to extract a portion of, let's say you have a batch of grain that's fusarium infected. If the level of toxins is too high, it's in the best scenario going to feed. Worst case, it will be salvaged. But what we can do is we select the portion of the grain that has the highest contamination of fusarium, and we simply remove it. And in that way, you can recover a batch that was previously discarded. A third way of using it is and this is more focused on the subsequent processing of the material. You can introduce another threshold, making it even more complicated, but this allows you to then create a very, very homogeneous quality of grain that will be a lot more predictable in your process, whether it be milling or malting, brewing. And if we look at this image, you can see that basically we have two outlets on the machine. So one outlet will be the middle fraction, and the second outlet will be a combination of the two outer fractions. And the funny thing here is that although the middle fraction we would consider that higher quality because it's more uniform. If you measure these two products in the lab, the combination of the outliers, compare that to the middle fraction, it will not be possible to tell the difference between them because they average out at the same protein content, if that's what you're looking for. So just to sum up, BoMill technology turns challenges into profit. So the challenge of increasing quality variations that we experience, the current sorting technologies are really good at what they do, but they are limited to removing a small portion of impurities. So you could never do a 50-50 split, for instance, as I showed you earlier in the images. And they are restricted to properties or superficial properties such as size, shape, and color. The BoMill solution, on the other hand, addresses variations on the inner properties and are able to extract premium fractions or remove contaminated kernels. Also possible to produce homogeneous fractions, as we touched upon earlier. So the agricultural industry or the grains industry is quite big. So you really need to focus. And in our case, we have focused on two applications or two markets. So it's flour milling in Europe and malting in Latin America. And this is mainly due to the fact that we have seen that these two markets are the ones that make the most sense to us today. It's not that we want to exclude markets, but this is where we see that we get the most traction at the moment. And being focused is really key in this industry. So if I start by talking about barley in Latin America. So Latin America is one of the biggest or fastest growing markets for beer consumption. And to make beer, you need malting barley. Malting barley, the varieties available are not really suited for the Latin American climate. So this means that you have big issues with the quality that you get from the harvest. So it's partially the climate, but it's also the experience of the farmers. If you compare to, for instance, Europe, where people have been growing barley for a very, very long time, the quality is a lot more stable than it is in Latin America. And this is also what made us focus on Latin America. So what you experience here is that you frequently end up with grain or barley that is out of specification for protein. Sometimes you also have issues with DON, but one of the main problems would be protein content. It simply ends up too high in most cases. And so in order to reduce costs, now I'll show you an example here. So let's say you have malting barley produced in Latin America. Some of it will fall outside of the desired specifications, and this will then be downgraded to feed. But instead of downgrading it to feed, you can now run it through BoMill's Insight, and you can recover all the grains that are within the desired specifications. So you limit the amount of grains that are being feed graded. And this is a huge saving for them, both in terms of money, but also in terms of the consistency and predictability of their businesses. They simply know how much, they have a more accurate idea of how much domestic grain they will be able to produce from year to year, and will be less vulnerable to weather phenomena or extreme weather that might hit the crop in a negative way. We can also look at improving the process efficiency here. This is something that we will that we have started a little bit looking into, but we will spend spend a lot of time next year looking into the benefits that the homogeneity can bring to the processing of malting barley. So you have 3 steps when you do malting barley. You steep it, you let it germinate, and then you kiln the barley. So basically you, in the first step, you put it in water, it absorbs water. If you have a more uniform product going in, this step will be much faster and it will require less water. The second step is germination. That's where you basically modify the grains. They start growing and they start not releasing, but transforming some of the starch to sugar. This step can also be improved. And then you have kilning, which is the final step of malting, where you basically dry the grains and stop this germination process. And here you can also, by having a more uniform product, you can use less energy when you do the drying. So to summarize that, using our technology in this area, you can optimize the local barley supply by recovering downgraded material. And on top of that, you can also optimize the malting process. So our
Hansi, we do have a couple of questions if you're willing to take them now.
Yeah, hit me. It feels like I don't want to take up all the time.
No worries. So the region that we serve, North Dakota and Montana, produces a fair amount of barley. So the question is, how practical is this to install in a country elevator prior to shipping to customers, i.e. segregate what goes to malt versus feed versus other channels? Is this designed more for the malt house, or is this something that could be in an upcountry shipper, I think is the question. And I think part of that also comes down to the capacity, right?
So the capacity, as I mentioned, has been one of our previous challenges. We are now at 15 tons per hour, 15 metric tons per hour for one unit. They can work together in a cluster of up to 8 units. So you're getting up to 120 metric ton capacity. The most ideal place to put them is in an elevator, simply because of the logistics. You don't want to ship something to a malt house and then have to ship back half of the product. But most elevators require a very high capacity. So it's, I would say that's the best spot to put it, but there are also some challenges related to that. So you need to have a large enough quantity of out of spec material for it to be feasible. And that's what we see in Latin America.
The second question comes down to labor. So how much, what additional labor is necessary to run some of these units? So when you look at country grain elevators, they're usually very short on labor. So I think that's part of the concern, is if you're going to install this in some place in Montana or North Dakota, having extra hands to run this at harvest or even throughout the year is a bit of a concern. Can you comment on that?
Well, that's also something that we have experienced in the market. People don't have excess labor simply because it's very expensive. So we have put a lot of focus on making this as simple as it possibly can become. So, and I will touch upon that later in the presentation as well, but it is simple to run. It doesn't require any frequent intervention of operators.
I think the last question, unless people have some additional, you talked about segregating based on protein, but also on DON. There's multiple different markets for barley, feed, malt for beer, and malt for distilling. Can you comment on how you could segregate for all three? Is that going to? I think the question is that going to require more than one pass, or is that something? How could you manage
typically
that?
Yeah, I mean, one of the early models that had lower capacity of our technology had 3 outlets, but our experience was that all the customers were only using 2 fractions, and that's simply because most batches are not covering the full range in terms of variation from feed to all the way to distilling. Basically, what you'd see is that you have a batch that is just between distilling and malting, or one batch that's between malting and feed. So in the end, you would only have to do 1 pass.
Very good. I appreciate it. I think that answered the questions so far. So I'll let you get back to it.
Yep. So the second targeted market we have are European flour mills. And this is quite exciting because it's near to our home. We are based in Malmö in Sweden. So we actually have 1 machine up and running now. Despite this product, I didn't clearly mention it, but the machine has it was launched in January this year, so it hasn't had a lot of time on the market. But one of the units is up and running in Germany, and it has processed over 1,000 metric tons without any interruption. And I will just briefly touch upon the sort of the circumstances that makes this an interesting market for us. So I mentioned earlier that Europe is a very mature market. We have been growing wheat, we have been growing barley for a very long time. One of the problems now with the focus on sustainability is that there being legislation, or we are introducing in the European Union legislations on the use of fertilizer. So you cannot put in more fertilizer than the crops pick out of the ground. So this results in lower protein in your wheat, and that in turn increases the premiums for high protein wheat that is desirable for applications within or certain types of flour that require high performance, I should say. So this is just sort of an overview of what you do. You basically take your standard milling wheat, which is around 11.5 to 12%, and then you extract the high protein wheat from that and use that for specialty flours. Usually the most demanding flours would be for industrial baking, where you need to have the same consistency from batch to batch. Otherwise you would clog up the machinery. But when you remove this high protein wheat from your standard wheat, then you have lowered the protein content slightly for the second fraction. Well, turns out this is well within the requirements for retail flour, for instance. So the flour that you and I can buy in the supermarket, because we are not, we don't demand that quality. We look at the dough and see when it has fermented enough, and then sort of you can deal with the fluctuations in quality. So I will give an example here of the actual business case. So what has happened over the years is that well, a bakery or a flour mill would buy two main ingredients. So you would have the standard B wheat, and then you'd buy a certain amount of A wheat that you would add as a performance booster. Because of the legislation and reduced fertilizer, you're now paying a premium of somewhere around 20 to 30 euros extra per ton of A wheat, something that used to be down at 5 or below 5. And so by taking the B wheat, running it through our equipment, you can make artificial A wheat. So instead of paying $30 extra per ton, you pay roughly $2.50 in running costs per ton to generate the A wheat. So that's a substantial savings for these mills. And this is also backed up by the baking tests. So they actually tried to make a mixture of B wheat and A wheat, and tried to do the same mixture with B wheat and the artificial A wheat, the A wheat that was picked out of a batch of B wheat, and it performs the same. So I'm going to go very, very briefly into the machinery, because I think that this presentation aims more on the overall idea of, or the concept of single grain sorting. So the product, as I mentioned earlier, it's using it's basically a single kernel sorting using near infrared transmittance. Near infrared transmittance is what the lab units are using, but with more high-end detector. So a capacity of up to 15 metric tons per hour, but because we have made it a modular design, you can have it all the way from roughly 2 tons an hour. So in this image, you see that it's almost like 8 cassettes hooked into a docking station. So each of these cassettes have just below 2 tons an hour capacity. So a full unit is then 15 tons. And this modular design makes it extremely easy to install, operate, and maintain. So the installation we did in Germany, when we arrived with car to the facility, it took 2.5 hours until we had the machine assembled on site. We did not have to move any of the existing equipment. We actually do an IKEA style installation with these units. So they come in sort of a flat package. So the door where we actually managed to carry this machine through was 60 centimeters wide. So Dylan, you would have to help me translate that. Is that sort of 2 feet or something? Yeah, let's say it's more narrow than a regular door. So 2.5 hours, you didn't have to move anything around. And they started out with two units. So 2 sorting units, basically 2 of these cassettes. So we installed the frame, and they could, or the docking station, they could hook on everything from electricity, compressed air, incoming product, outgoing product, aspiration. Everything was done in advance, and then we just simply plugged in the sorting units. The same thing if they want to increase their capacity to, let's say, 15 tons an hour. They just order an additional 6 units, and we just come there, plug it in. There needs to be no additional work made to facilitate that. Everything is already prepared. And as you saw, the bell curve that I showed you earlier, that's basically what you have. You have one slider, that threshold that you can move back and forth to target your protein content. You don't have to do any weird calibrations or adapt light sources or make any mechanical calibrations. It's just a one lever to pull on. About BoMill as a company, we're based in Malmö, which is in south of Sweden. We have extensive know-how in single kernel sorting. We have done this for over 15 years now. And we have in-house expertise on all the key components that go into our technology. So everything is done in-house. So we have mechanical competence, software competence, and electronic competence, just to ensure that we are on the cutting edge of this technology. As I mentioned, we are working in Latin America. That introduces a problem, the problem of distance. So in order to help out with this, we are in partnership with regional distributors. And that is in order to be able to have a strong international presence. So for instance, we're working together with Bratny companies, a well-established player in the grain processing industry. They have a dedicated BoMill product manager who's also with us here today. So it's Dylan. And Dave is also helping out there. They also have one of our units at their facility for demonstration and testing purposes. So that's going to be, yeah, I think that's rounding off the presentation of the company and so on. But this is how we work. We use well-known distributors all over the world. They can help us to do turnkey installations, which would be very hard for us from all the way from Sweden to do. So we're really, really happy with this partnership. So as a final conclusion, we have increasing challenges in the world today. We have an increasing population, but we don't have an increasing amount of land. We basically have to deal with what we have. And on top of that, we have climate variation, which is negatively affecting the quality of our crops and making the quality also a lot more unpredictable. But there is a variation found in all grain. Every grain has variation, some smaller, some bigger, but all grain has this variation. And this provides an opportunity for us to deal with these quality challenges. BoMill provides the solution to make every kernel count. We can make sure that all the grains that are of the right quality can end up in the right process. We also have proven business cases for these two markets that I told you about earlier, the Latin America barley market and the European flour milling market. And this technology is something that you cannot afford not to look into as a company working in the grains industry. And with that, I would like to thank you all and strongly encourage you who are listening or seeing this later on, streaming it from the homepage, reach out to us. We have presence in US via Bratney. I've also included here Dylan's email address. Please reach out to him. You can come and visit them in Des Moines. They have this equipment. You can bring samples that they can run on it, and you can see what this technology can bring to your business. It's really something that you shouldn't miss out on. And of course, you're also much encouraged to reach out to me as well. Yeah, thank you very much for your attention.
Thank you very much. And we do have time for questions. We've got a couple of them rolling in. I'm going to try and there's some on wheat and flour, and there's some on other grains. So I'm going to try and segregate these out a little bit. So you did a nice overview of how BoMill can help the flour milling industry. The question came in, when you look at the variation in this year's hard red winter wheat crop throughout the US, is this a technology that would allow millers to better segregate for their mills? And can you address that a little bit when you start looking at the US miller?
Well, we have just started looking into the US market. I think Dylan might be more suitable to answer that, but I know for a fact that there is a place for this technology in the US market. Exactly what it will look like is not 100% clear to me. That's also why we have taken the investment of putting a machine at Bratney's facilities to investigate this and see what benefits can we bring and where does it make the most sense to put this equipment.
Yeah, Hansi, I think you answered that question well. You know, there's certainly going to be greater opportunities in certain years versus others, but it does have a place in the flour milling industry to help better sort protein, to have a more consistent wheat on the mill. You know, I think you know, we're looking into the qualities and efficiencies of it, but you know, the more uniform the wheat is to first break, the more it's going to help their yield. So it certainly has a place over there, and also in years where you have wide protein spreads in terms of price, it's certainly easy to see the benefit there. Same in the case of vomitoxin. You know, some years the discounts for vomitoxin, and even some issues with just sourcing enough good wheat in certain areas when vomitoxin is a big issue. This machine's going to help out immensely.
There's a lot of concerns around the world in the flour milling industry. This year, it seems like in particular around feed wheat. Can you talk a little bit about how this might, when the world has a lot of feed wheat, how that can try and help segregate that market? Is this technology that can help with that?
I have not spent too much time looking into the feed wheat market. I would say if there is quality differences and different premiums, then there is a need for this technology. but I would say feed is typically a cheaper commodity. If you have feed that contains high quality grains, that could be one opportunity. We see that in the barley market in Argentina, for instance. They export a lot of feed simply because it's easier to export in terms of administration. So you don't need to have as much paperwork done to export barley as feed. So you have a lot of malting grade quality that's being exported. So if you can buy that and then upgrade it, then you're in for then you might have a business going for you there.
I think part of the issue comes down to, and I think you highlighted it well, it's that variability, right? A lot of that feed, you're having rain at harvest time, it's causing quality issues. So if it's quality issues, it can be your technology should be able to segregate some of those quality differences out, correct? The next question, and I know this is going to vary, how is the ROI looking for a standard business case for this?
Well, let's start with that. There needs to be an ROI in order for someone to invest in this equipment, simply because it has not been adopted as an industry standard yet, as you can see for some of the grain cleaning equipment that's available on the market. What we typically see is that the ROI is somewhere around 12 months, 12 to 13, 15 months. But that also, it strongly varies with the premiums of the different qualities. But when people make decisions, it's typically when they have an ROI showing that you're somewhere in the midst of 1 to 2 years ROI.
Very good. Going to shift the focus a little bit towards some of the other grains, if that's okay. I know you're focused on barley and wheat here today. So we do have a number of people from other cereal industries on with us today, and they've got a couple of questions. The first one revolves around durum. So there's a lot of concerns in the world today around durum supply, and durum quality. Would this technology be able to help the durum industry in segregating and finding good quality durum?
It depends on what the quality parameters would be that you're looking for. So we have mainly focused on protein. So it works fairly well with protein on durum wheat, but mainly on the lower end. So if you have problems with contamination of low protein durum wheat. But we have looked into that market, but we haven't really seen as profitable business cases as we've seen in the European flour milling market and the Latin American barley market.
What about other specialty grains? And it may not be an opportunity that you've necessarily explored, but as long as there's some segregation around protein, this technology should work, shouldn't it?
Yeah, with some adaptations in some cases. So preferably you'd like to have grains that are within the same size as wheat and barley. A lot of inquiries that come in are for purity sorting. And so that's an area of interest. It's just that it's the R&D is quite cost intense. And so we need to establish 1 or 2 markets first where we have recurring sales and where we have a strong market before we start spending any money on R&D for new traits. But being of the R&D background, it's very, very how do you say, enticing, the thought of of exploring all the alternatives you have.
But the applications, if it's something similar to a wheat or a barley, so if it's a rye or an oat or it should be applicable. If it's a sorghum today, you may not, a sorghum or a millet or a teff, you may not quite be there. Would that be accurate?
Yeah, that would be somewhere in the future, but not in a very far future, I would say.
Very good.
It all depends on where we see the business cases. That's where we're going to put in the most effort.
Very good. Are you able to detect discolored germ in wheat?
No, I would say we have not looked into that, so I couldn't really tell.
Okay.
I might answer that too, that you know, that may be something that's done with a color sorter, for instance. You know, that's probably because that's a superficial look, and color sorters are highly accurate in that aspect of it. So that may be something that and again, just very quickly, we have a test lab that has the BoMill, the Insight system in it. But in addition to we've got that lab, we have screeners, cleaners, we have color sorters and other equipment that we would run tests on. If anyone is interested, they can certainly send us samples and we could send back the results.
Very good point, Dave. So it's a very well-equipped workshop or lab that they have. So you can really investigate what is the most suitable technology for my particular problem. And it's not always going to be the BoMill. I hope for many cases it's going to be, but I mean the equipment that's already on the market, like color sorters and traditional cleaners, are doing a really good job at what they do.
So the BoMill is certainly a part of the solution, but it might also be a combination with some existing technology as well.
Yeah, so let's take the German mill. They have already 5 fully equipped Buehler color sorters running in their facility to pick out discolored grains or broken grains. Those machines are really good at that, but they are not anywhere close to where we are when it comes to picking out proteins. And believe me, they have tried. It's just that it's not really a suitable technology for looking at protein when you have a color sorter. It has a lot of benefits, but in other areas.
Very good. I think I know the answer to this one, but I'm going to ask it since it did come from the does this technology work based solely on protein, or does it or special, for example, are you able to tell gluten strength, or is it just crude protein?
It would be more correlated to crude protein rather than specific gluten strength and so on.
Very good. So it's still, if you're a flour miller, you still need to do your normal testing, but it certainly helps in that segregation. And we know crude protein is certainly it's an important factor when you're milling.
Yeah, so just send the samples to Dylan and Dave, and they will tell you what's inside.
Very good. I think we've run out of questions and we're almost out of time. So any closing comments from any of you?
Well, really happy that you invited us to present here.
And I would echo that, you know, any feedback or general feeling of what you've seen and how that might come to be would be very helpful for us as we develop these markets. You know, we want to get a pretty good idea of what we see out there, but your people are more on the front line, and if you can share any feedback, we would welcome that.
Yeah, and I would add that if you're in the US or anywhere else, from Hansi's sake, but if you have a certain application or area you think you may want to look at putting a BoMill, we can come out on site and help look at that space for you. see how it might fit within your specific process. So we can help with those things as well.
And I know it's been said that you guys do testing. How big of a sample size? So if somebody said, boy, I'd like to see what this can do, how big of a sample would you be willing to take at your facility in Des Moines?
Yeah, Dylan, you want to answer that?
I'd say, you know, to start with, probably, you know, a couple 100 pounds, if we could get that. And then based on those results, if any further samples are needed, we could proceed from there.
That sounds good. All right. Thank you very much. We appreciate the time. We appreciate the presentation, and thanks for all of you for joining us. So hopefully we'll see you back.
Thank you very much, Mark.
Thank you.
Thanks, everyone.